Hi everyone, today I'm going to do the worked examples from 8.3 of the jacplus text. So this is finding area under curves. The first one, we are given a exponential graph and you should draw it. Of course, there's an asymptote of y is positive 3, but I don't really need to show that. The the important things are that I draw the shape of the graph, that I can see clearly where it's in the positive zone and where it's in the negative zone, and in this case the whole thing is in the positive zone, and that I put the x values of 0 to 3 in this case, and shade the area that I'm trying to find. So this is the area I'm trying to find, and it is an entirely positive area because it's above the x-axis. So this area is going to be found by doing the definite integral of e to the neg x plus 3 dx, and that's going from 0 to 3. So we can just antiderive. So that's neg e to the neg x plus 3x from 0 to 3, and now of course subbing in. And subtracting neg e to neg 0 plus 3 times 0, and be careful because subbing in zeros, people will just cancel things out when actually you definitely can't do that, because as we can see in this case, this is going to be negative 1. E to the 0 is 1. That's negative 1. The 3 times 0, of course, still stays 0, but you've got to be on the lookout for where you get something other than 0. So this is going to be 9 plus 1, which is 10, minus e, I'll write it as 1 over e to the 3. And my units is nothing specified, so I write square units. So that would be our answer. Let's look at the next one, and here we have the area bound by this curve and the x-axis from neg 2 to 2. So what I would do if I were you, I would expand this. So x squared times x squared is x to the 4. X squared times neg 4 x squared minus 1x squared, that's going to be negative 5x squared. And then neg 1 times neg 4 is plus 4. So that means that when I do my anti-differentiation, it's ready to go in the expanded form. So let's draw this. X-intercepts will be when y equals 0. So x can be plus or minus 2, and x can be plus or minus 1. And that graph will look like, let's see, neg 1 and neg 2, and 1 and 2. And it's a positive graph, so it will go like this. So now we have to see what part of the graph we're trying to find the area. So from neg 2 to 2. So that's going to be this part. It's bound by the x-axis and the curve. This part. And this part in here. And what we have to recognize is that this has some negative areas. So this is a negative area and this is a negative area. This area here is positive. So when we, if we were to say 5 minus 7, for example, then 5 minus 7 would equal negative 2. If we wanted to make that positive, well, you could times it by negative 1. So that would equal positive 2. Alternatively, if you were to flip these and say 7 minus 5, you would immediately get a positive 2. So with that in mind, let's look at what we do with the negative areas. So I'll just rub that out because the 5 and the 2 and the 7 don't have anything to do with it. But keep that in mind, because if we find that this area is, say, negative 1 square units, and it's not, I'm just making that up for the sake of having a negative area. Well, secondly, this would be negative 1 square units because these are the same, they're the same amount in there. This one here, well, that would be a positive area because it's above the x-axis. The green ones are below the x-axis. So just say that this was 2 square units. So what we'd get overall, if we were to add that together, we would be saying that that area is 0. and you can see quite clearly that it's not 0 at all. So if we want to find our green areas as positive areas, we could multiply them by -1. But also what we could do when we antiderive, we could flip the, when we integrate rather, we could flip the terminals, and I'll show you how that works. So let's set up our definite integral. So area, I guess our area equation is going to be, so the positive area, which is from -1 to 1, and if this was f of x, we could write f of x dx, and then we could say plus 2 times, and either we can times it by -1, which would mean it's a -2 here, or instead of doing 1 to 2, so the lowest to the highest there, we could do the 2 to the 1. You can't do both of them though, because then you're doubling, so you'll end up back to the negative. I like to flip the terminals. Now, because it's not called f of x, I'm going to write the actual equation there, but I wanted to put that because if this was in a SAC or exam and it was called f of x, you would get 1 mark for putting that area equation, and you wouldn't need to write the whole thing out. You could just use f of x, particularly if you were using CAS. Then you can just pop it into CAS without having to write everything out. So we've got x4 minus 5x squared plus 4 dx, and I am going to be adding 2 of the green areas. Flip the terminals, so let's do 2 to 1. I could have done -1 to -2 instead. I just am choosing the positive because it's easier for the substitution. So here would be our first, or our area equation here, written nicely, making sure that we account for the negative area. And then, well, we would antiderive, so that's 1/5 x to the 5 minus 5 on 3, x to the 3 plus 4x from -1 to 1 plus 2 times, it's the same antiderivative here, from 2 to 1. And it would take quite a long time to sub these in by hand. Some of the questions are by hand. I'm going to cheat and do it on CAS in a minute, but we would, just to let you know, you must be very careful with your brackets. So I'll sub the 1 in, minus, let's sub in -1. It's going to be -1/5 plus 5/3 minus 4. And then I would be adding that, I'll do it on the next line, to 2 of these. So it would be 1/5 minus 5/3 plus 4 minus 2 to the power 5 is what? 32. Minus 2 to 3 is 8. 8 5 is 40. On 3 plus 8. And then, you know, you could common denominator, all that sort of stuff, add it together. The answer for this one, and I have done it on CAS earlier, is actually 8 units squared. So all that work and we get to 8 units squared. Under usual circumstances, you wouldn't get something which is so involved in and so much room for mistakes if you don't have CAS with you. So look, when you are doing them by hand, there is a lot of risk for making just a little mistake. For example, you know, if you had to the power of 5, you know, 2 to the power of 5, for example, you know, you might write 64 by mistake, and then your whole thing would be wrong. In any case, the answer is 8 square units, and the big ideas there are to look out for the negative area. And that completes the worked examples.